Hello, this is Dave from Dimensional Consulting. Today we are going to talk about external boundaries as simulated by variable-size datum feature simulators as shown in Figure 7-24 in the ASME Y14.5 2018 standard. The figure looks something like this slide. The goal in this figure is to calculate the maximum external boundary at datum feature D. The boundary will be a diameter that fits around datum feature D. The boundary will be a variable boundary, and it will be different for each part produced. We will look at the largest that it could be. The diameter of this boundary will be different depending on which datums are referenced in the feature control frame that references datum D. We will look at the feature control frame for the position tolerance that controls the location and orientation of the 2.2 diameter hole. We will calculate what the maximum possible boundary will be for each of the three options for how datums might be referenced. In each case, the boundary's diameter will be the same as the variable size hole in the gauge that we will use to establish our datum reference frame. When the feature control frame references only datum feature D, the max possible boundary is calculated without regard for location or orientation relative to any other datums. The max possible boundary will be the smallest boundary that will always fit around datum feature D without regard to any other datums. That boundary will be equal to the largest allowable size plus the amount that it could bend. Therefore, it is the largest size of 7.9 plus the straightness tolerance of 0.1. We see the datum feature simulator in brown. It is just a variable size ring that surrounds datum feature D. The maximum that the hole in this ring would need to be is 7.9 plus 0.1, which equals 8. When the feature control frame references datum feature A primary and datum feature D secondary, the calculation includes the orientation tolerance relative to datum A. The ring must always fit around datum feature D when taking into account the perpendicularity tolerance relative to datum A. Remember that datum feature D could already fill an 8 diameter boundary just from its size and its straightness error. Now that 8 diameter boundary could tilt relative to datum A. Therefore, since the ring that fits around datum feature D is now exactly perpendicular to datum A, the diameter of the ring that will always fit around datum feature D when datum feature D could have perpendicularity error is equal to that 8 diameter boundary plus the 0.3 that it could tilt. We see the datum feature simulator in brown. It has a surface to contact datum feature A. Perpendicular to that surface, it has a ring that surrounds datum feature D. That ring must be able to be as large as the 7.9 largest size, plus the straightness tolerance of 0.1, plus the perpendicularity tolerance of 0.3, for a total of 8.3. When the feature control frame references datum feature A primary, datum feature B secondary, and datum feature D tertiary, the calculation includes the position tolerance that references both datum feature A and datum feature B. The boundary will be the smallest boundary that will always fit around datum feature D when taking into account its relationship relative to datum features A and B. Remember that datum feature D could already fill an 8 diameter boundary just from its size and its straightness error. Now that 8 diameter boundary could tilt relative to datum A and move relative to datum B. Therefore, since the ring that fits around datum feature D is now exactly perpendicular to datum A and exactly located to datum B, the diameter of the ring that will always fit around datum feature D when datum feature D could have perpendicularity error and location error is equal to that 8 diameter boundary plus the 0.6 that it could tilt and move. We see the datum feature simulator in brown. It has a surface to contact datum feature A. Perpendicular to that surface, it has an expandable pin to go inside datum feature B. Perpendicular to A and perfectly located to B, it has a ring that surrounds datum feature D. The ring that goes around datum feature D must be able to be as large as the 7.9 largest size, plus the straightness tolerance of 0.1, plus the position tolerance of 0.6, for a total of 8.6. That's today's video. If you want to see more tips like this, please subscribe. And visit my website at dimensionalconsulting.com.